Hello everybody, this is Dr. Kalpana Chauhan. Today I am going to discuss about the frequency response of continuous time LTI systems. The output of a continuous LTI system can be represented as the convolution of its input and its impulse response. If we apply the convolution property of Fourier transform, then we get the output in the form of the multiplication of input and output, input and the system response, where y omega and x omega, h omega are the Fourier transforms of yt, xt and ht respectively. Here if we write this equation in terms of h omega, then get this equation. This is nothing but the frequency response of the LTI system. Here h omega can be represented in terms of its magnitude and phase response like this. This is the magnitude response and theta h omega is the phase response of the system. Now we are considering the complex exponential signal xt is equal to e to the power j omega naught t, which having the Fourier transform h omega is x 2 pi delta omega minus omega naught. Then we can write the output with this input is equal to 2 pi h omega naught delta omega minus omega naught. Now if we take the inverse Laplace transform of y omega, here we are taking inverse Fourier transform, then we get the yt is equal to h omega naught e to the power j omega naught t. It indicates that the complex exponential signal e j omega naught t is an eigen function. This is the eigen function of LTI with eigen value of h omega naught. Now if we are assuming that xt is a periodic signal, here we are considering another case that xt is exponential, then we can write it as, and if xt is and its yt output corresponding to this exponential input can be represented in the exponential form as well, like this j k omega naught t. Now if we are assuming that xt is non-periodic, in this case xt can be represented j omega t d omega, and the corresponding output yt can be represented as 1 upon 2 pi minus infinite to infinite h omega x omega e to the power j omega t d omega. Now thus the behavior of a continuous LTI system in the frequency domain can be completely described by its frequency response ht. Now let x omega, we are writing here in terms of its magnitude and frequency responses and y omega is equal to it's to the power j theta y omega. So we can represent it. We are writing y omega. It is the multiplication of magnitude of input and the magnitude of the impulse response. While if we try to find out the phase response, then it is the summation of the input phase and the phase response of the impulse signal. So this is all about how we can represent the continuous frequency response of continuous time LTI system with different inputs, whether it is in terms of periodic or non-periodic, and how we can represent the magnitude in terms of the magnitudes of input and magnitude of the impulse response of the system. Here all things we have discussed in this lecture.